you're doing well. This is our first lesson of our new unit, Unit 3. And we are going to specifically be focusing on distributive property for this lesson and really for the rest of this week here. And so if we're reading this together on the top, just a reminder, remember how you used to multiply out larger numbers. Likely you've done something like this in the past. And so really for these next few days, we're going to be working on just how to multiply different set of terms, different set of numbers, being able to come up with a full algebraic expression. And so just to start off here as our example, we have 5 times 24. So you might have learned it one way, you might have learned it another way, but I'm going to show you how to do it using these what we call generic rectangles. And I'm just going to write that here just so we have reference of what they are. So again, generic rectangles. So what we're going to do is we're going to fill out the boxes to represent the problem. So on the first box here, we're just going to write on the left side 5. On the top, we're going to split it up and we're going to write 20 and 4. And really this is the same thing as writing 5 times 24 is the same as 5 times 20 plus 4. And so even though we might not know how to multiply these bigger numbers right away, the thing that we have to keep in mind is that we're just multiplying the rectangles to get the area inside. And hopefully we have learned how to find the area of a rectangle. It's just length times width, or how we like to say base times height. And so in this case, the first rectangle that we see here is 5 times 20. So we have to find the area of this. So 5 times 20, if I plug that into a calculator, if you do it on top of your head, it ends up getting 100. And then we have our second rectangle on the right side. That's 5 times 4. So if we notice, the height is still the same, but we have to multiply by a new thing going on here. So I'm going to show something real quick. So with the 5, with the 20, but now with a new color, we have 5 and 4. So now we have to do 5 times 4, a little bit easier than 5 times 20. Or 5 times 20, and 5 times 4 ends up with 20. And so overall, to get our answer, we just have to add these two numbers inside together. So we have 100 plus 20 equals 120. And that doesn't work. So give me 1 second. So 100 plus 20 is equal to 120 in total. So that is our answer for this question. So basically, again, just to repeat what I did, I wrote down the side lengths of my huge generic rectangle, and then what I need to do is to find the area of each little individual rectangle. So I did 5 times 20 and 5 times 4 to get 120 respectively, and then we just add these two numbers up together to get our full answer, which is 120. So let's do our little guided example here. On the left, we have 8 times 56. So if I'm going to split this up here, I want to write this as 8 times 50 plus 6, just like how they did it over here. So on the left side, I'm going to put 8, and then on the top, I'm going to do 50 and 6. So now we just need to multiply these two numbers together, these two sets of numbers together, to get what's inside the rectangles. So 8 times 50, if we do that in our calculator, we should get about 400. And then 8 times 6 is going to get us about 48. So just to show the different colors here. So I'm multiplying the 8 and the 50, but I'm also multiplying the 8 and the 6. So now my last step here is we got to add these two together. And so we have in the middle 400 plus 48. And when we add these two numbers together, we do get a total of 448. Let me tidy this up a little bit too. So 448 is the answer here. So let's do the your turn together. So now it's asking, show the diagram for 7 times 32. What is the product? So it's going to be similar to how we just did it. Make a big rectangle. 2 parts in the middle. On the left, it's going to be 7. And then on the top, we have to split up 32. So we can just do 30 and 2. So now when we multiply these two together, it's going to be a little more straightforward. So 7 times 30, I'm going to do this in orange. If we plug that into our calculator, we get 210. And then I'm going to do the 7 and 2 in blue. 7 times 2, a lot easier. It's going to be 14. And so totally, when we add these two numbers up together, 210 plus 14, we get 224 as our answer. Okay. So if you guys notice, the process is the same for all of these three examples that I've done so far. So now the next step is just figuring out how to get the rest of these guys. And so something to note here, there's a little puzzle that they wanted us to solve. And so I know it's a little cut off, so I'm going to rewrite it. So it's going to be 4. Ooh, that was not good. We're going to get 4. And then 20. And then this is going to be a question mark. We have 80 and 88. And then over here, this is the question mark. This is 12. And this is 4. So basically, we're just trying to figure out how do we get to this 88? Well, right now I have 80 in here. So basically, 80 plus this is equal to 88. So what adds to 80 to get to 88? Well, hopefully see what all we need to do is just add number 8. Because 80 plus 8 is 88. So that means 8 is going to go inside our second rectangle here. But then what has to go on top? That's our puzzle. What do we have to put it on top? Well, basically we're answering the question, 4 times something is equal to 8. Well, 4 times 1 is 4. 4 times 2 is 8. So we don't have to put the question mark anymore. We can replace it with 2. And so our answer here is 2. The question mark is equal to 2. Okay. It was really hard for me to draw these boxes. Okay. So now for the puzzle here, this time we're missing the left side of our rectangle. We're still given the 36. We're given the 48. So basically, we need to ask the question, well, what goes in here? So 36 plus something is equal to 48. Well, if we treated this like x, then all we need to do is subtract 36 from both sides. So when we do that, we get x is equal to 48 minus 36. If we plug that in, we do get 12 as the inside. So I'm going to replace the x now, since I know it, with 12. So now comes the question, what's the question mark? Well, if we take a look here, it's question mark times 4 is equal to 12. So then what multiplies 4 to get to 12? Well, we can sort of guess and check like we did this question, or if we want to do this a little more mathematically, we can divide both sides by 4 because that's the opposite of multiplying. So when we do that, this cancels. So the question mark is equal to 12 divided by 4, which is 3. So 12 divided by 4 is 3, and that's going to take the left side of the question here. Okay. All right, so now we're going to get into the questions that's going to be a little more what we're going to see for these next few days. And so if we notice, we're not given just numbers anymore. This time we have an x. So don't worry about it too much. It's still the same process. So I'm still going to put on the left side, I'm going to put 4. But if you see in the middle, in the parentheses, it's going to be x and 7. X and 7. And I don't really have to put the plus sign, but if it makes you guys feel comfortable, you can put the plus sign there too. It doesn't really do anything. This matters especially when we're doing this next question down here, when there's a minus 3. So just so that you're aware. Oh, I went too much. So I'm going to put 4x plus 7. And so now we got to start multiplying. So our first rectangle is 4 times x. There's nothing too crazy about this. It's just 4 times x. So that's 4x. And then 4 times 7, that gets us a number. That's going to be 28. Well, how do we add these two together? Well, here's the thing. Since in algebra, we always learn about combining like terms. However, in this case, there's an x on the left one, but there is none over here. So these are not like terms. So actually what we need to do is we need to keep these as separate terms. So to write my answer, all I need to do is just 4x plus 28. And that actually is my answer. That's all I need to do. So hopefully that one isn't too bad here. Now on this side, I know the numbers are faded, so I'm going to put a 3 here, x, and a 1. Okay. And actually, just to make sure on the document, this is a -1. So we're going to change things up here already. So there's an x minus 1 here. So again, still the same process. But here's how we write it though. We want to write our original question like this. So it's going to end up being 3 parentheses x minus 1. So I'm going to start multiplying here. 3 times x gets us 3x. 3 times -1, however, gets us -3. So when I multiply this out, it really just ends up being 3x minus 3. And that is our answer for the third question. Okay. So again, the only fundamental difference with this question here is we're not multiplying with numbers, we're multiplying with variables. So when you do a number times x, it's just that number x or number y or number b or whatever it is. So don't get too caught up, even though there might be multiple letters that are going on our variables. It's still the same process. It'll still be not that big of a deal. Okay, so what we've been doing is called the distributive property. It can make multiplying two large numbers easier. And you'll see this process, and honestly, you're going to use this process a lot throughout your math career at Centennial and even in the future as well. So as you saw above, it can make multiplying numbers and variables possible. In the examples before this, we just took a number times a binomial. And what a binomial is, it's an expression with two terms. So when I'm showing this binomial here, it's 4 and then x plus 7. So x is one term, and then 7 is the second term. Over here, x is one term, -1 is the second term. 3x is one term, -3 is the second term. So that's what we showed in this example. So while it is certainly possible to do the problem above without drawing the boxes, drawing them can make things much easier and avoid mistakes, especially as the problems become more difficult. And so we're going to do another example right here. So the example that we're given to here is 24 times 37. So this we need to split up multiple times. So how do we split up 24? Well, we just do it like our examples on the left. So I'm going to put 20 and 4 on the left side. And then I'm going to put 37 on the top. So 30 and 7. So we got to do some multiplying here. Just got to keep track of what we're multiplying. So I'm going to start with the top left rectangle. It's 20 times 30. So 20 times 30 is a pretty big number. If we plug that into a calculator, we do get 600 as our answer. 20 times 7, the top right, it's going to be 140. 30 times 4, 120. And lastly, 7 times 4 is 28. So when we all plug this into a calculator here, we got 600 plus 140 plus 120 plus 28. And when you plug all those numbers into the calculator and you add it together, we actually get a nice clean number of 888. And that's only possible by adding all 4 of these numbers together. Okay. So I'm not going to spend too much more time. I'll draw the diagram for us here. This is going to be a 2 by 2 rectangle because we have 2 double-digit numbers. So setting up, we have 30 and 2, 10 and 7. So just the same process like what we did over here. But then now we have our second example. We have x times x minus 3. So when we plug this in, the left side is just going to be x. On the top is x minus 3. So here's our question here. What is x times x? How do we write that? Well, x times x, if I were to just multiply it, it's just x to the second power. We've talked about this a couple of times. So when you multiply x times x together, it's going to be x to the second power, or what we call x squared. And then over here, we have x times negative 3, which is just negative 3x. So to write my answer, again, these are not like terms. Why? I'm going to highlight why. Because that 2 is the reason why. Over here, there's no exponent here. It's just x. So our answer, when we're writing it out, is just x squared minus 3x. And that is actually the simplified answer for this question. So I'm just going to set this up for you guys as well. So x, x, and then 9. If you guys want to put the plus, you can. So same process, multiply together, and then see what you get here. Okay. Now I'm going to do one more question for us before I end this video. It's already taken long enough. So this last example, this is like the prime example of how to make a generic rectangle here. So if you notice, we have a 2 by 2 rectangle. Why? Well, we see that we have two different binomials, meaning two different sets of expressions where they have two terms each. So I have a 2x plus 3, and I have an x minus 7. So I'm going to start filling in my rectangle on the outside first. So on the left, I'm going to put 2x and 3, and then on the top, x, and then negative 7 or minus 7. So just like that one problem on the top that we just did, I need to multiply through every single rectangle and make sure that I'm keeping track. So 2x times x, you can ignore the 2. We can just put the 2 there. And then it's x times x, which we just learned is x to the second power, x squared. 2x times negative 7. 2 times negative 7 is negative 14. And then you slap on the x. 3 times x is going to be 3x. And then lastly, 3 times negative 7 is negative 21. So before we add things up here, I'm going to ask the question, do we see any like terms? And in this case, we should see two sets of like terms. In fact, it's going to be this 3x and this negative 14x. And what I like to do is, I actually like to draw it so that it sort of makes like a little oval here. Because these two are the like terms, so I need to add them together. So when I write it out, I'm going to do 2x squared plus 3x minus 14x minus 21. But when I add these two together, it's going to make 2x squared plus, and then what's 3 minus 14? That's going to be minus 11x minus 21. And that is our full answer. So this is probably the most complicated thing for today, is being able to just understand, like, how do we write this out? How do we simplify it completely so that we just end up having one line? So we need to multiply correctly and make sure that we're keeping track of everything that we're doing. So just as a last example here, I'm going to move this over here to have space. We're making another 2 by 2 rectangle. So I want you to fill out using this expression and fill out the rectangle and do the same process and solve and simplify here. Okay, so as you guys are working, of course, if you have any questions, make sure at least you go back in the video, rewind just to see and just check how I'm doing the work. And of course, if it's still confusing, please do ask questions, and I'll help you out as soon as I can. All right. So thank you, everybody. Hope this helps, and we'll see you soon. Bye-bye.